The heart of Moncton lies a silent testament to the city's industrial history, the site of the former CN Rail shops. The shops are gone now, but their legacy has remained in the community's economy, in people's minds, and in industrial residues on the site. Before the land could be used again, it needed to be remediated, and people had to decide how clean is clean enough. Located on Canada's east coast, the city of Moncton owes much of its past success to the railways, which dominated local employment and commerce for almost a century. Especially the Moncton shops, which were located on a 270-acre industrial site near the heart of the city. The shops were a keystone of the community until they were closed in the mid-1980s. The land sat unused, surrounded by homes, schools, businesses, and parkland that grew up around it in its heyday.
I guess I've always wondered why, as it sat vacant for so long, it's like, okay, why aren't they doing something with this land?
What kind of cleanup are they going to do? According to what they say, it's not as bad as they thought it was. But how bad did they think it was?
In 1995, responsibility for the property was passed to the Canada Lands Company. This Crown Corporation is responsible for turning dormant, government-owned properties into productive sites in their communities. The corporation is guided by a vision of redevelopment that includes environmental and social responsibility. Canada Lands Chairman John Grant.
Sustainable development is really about what the earth can sustain in terms of our human population. For so often, we've looked at development as being purely what we can extract from the world's resources. We've now found that we've come to the end of that.
Across the country, the corporation has been a leader in community redevelopment. Canada Land's General Manager Harold Kenny could see the potential of the Moncton site.
We felt that there was a much more economic value that could be realized by the community. We should not only look at the remediation levels, we should also look at the most sustainable development possible.
Canada Lands asked Dr. Louis Lapierre, Casey Irving Chair for Sustainable Development at the University of Moncton, to help transform the site from a liability into an asset.
Taking the land as it is at the present time, because it certainly is not productive as it stands, and reverting it to a productive land base for the economic benefits of the city is to me very important.
The first step to achieving the goal of sustainable redevelopment is understanding the history of the site from a social and economic perspective as well as scientifically. In Moncton, the shop's history helps explain the community's strong feelings. As the main locomotive repair shop for all of Eastern Canada, almost a quarter of the area's population once made their living on this site.
Peak employment at the Moncton shops occurred during the 40s and 50s, just prior to the introduction of diesel locomotives. At that time, there were 6,000 or more employees working at the facility.
But with rationalization of the railways across Canada, the largest single employer in Moncton's history was eventually closed. Moncton soon bounced back, becoming nationally renowned for its diversified businesses and industries. But the shop's site remained a scar in the heart of the city. When Canada Lands assumed responsibility, the land had been vacant for almost a decade.
Right across North America, as we've industrialized over the last 50 years, we've left many of these sites that, unless clean, could not be used. The environmental and economic implications of excluding these sites from being integrated to the economy and the environment are costly. So we've undertaken the process of decontaminating or changing or reverting brownfields to greenfields.
The team knew that a successful brownfield redevelopment would have two important components that had to be addressed at the same time: a very large environmental cleanup and changing negative public perceptions about the condition of the land. Canada Lands asked scientific experts Scott McKnight and Tortney Vigerstadt to join the project team and plan the remediation of the property.
And I think the longer it sat empty, the more people wondered, well, why isn't something done out there? And then that might have become, well, it might not be possible to do something out there. Maybe it's so contaminated that everybody's afraid to do something out there.
We finally said, look, we've got to do a very detailed survey, and we've got to literally do it from end to end. Every square inch, we've got to know what's there.
3 surveys were performed. A geomagnetic survey revealed buried metal and infrastructure. Biological and geochemical surveys were also completed. The surveys showed the scientists exactly what contamination they had to deal with and where it was. The cleanup part of the project would focus on 3 areas: debris and wastes accumulated from 80 years of industrial activity, pockets of hydrocarbon contamination, and traces of contamination in the soil and water. The project remediation team tackled debris first, deciding to reuse and recycle everything they could and to find safe disposal for remaining materials. There were massive concrete foundations and infrastructures that had to be excavated. About 120,000 metric tons of concrete was removed, half of which was crushed and stockpiled for reuse on site. Another 2,000 metric tons of landfilled scrap steel was dug out and sent for recycling, some into new steel rails. The survey also turned up some hazardous surprises that needed special attention, such as 56 buried compressed gas cylinders. A special SWAT team removed the cylinders, some still filled with acetylene and ammonia, and took them for testing and safe disposal. The team also found a dumping area for lead-contaminated foundry sand. 350 truckloads were sent for safe disposal and metal reclamation. And safe disposal sites were also found for small amounts of landfilled industrial wastes that are today considered hazardous, like asbestos from brake linings and discarded lead paint. One area of the site was impacted with spilled diesel fuel, and the team found an abandoned tank of used lubricating oil. 30,000 metric tons of soil were excavated, and saturated soils were heat treated on the site to remove the hydrocarbons. With the huge amounts of debris removed and the hydrocarbon contamination treated, the team turned to its biggest technical challenge: managing very small amounts of critical contamination in the groundwater and soil. In the groundwater, deep under the surface, traces of degreasing solvent had been found. The team could find no abandoned tanks, so they dug a hole 15 meters deep into the bedrock. The investigation proved there were no hidden pools of underground contamination, only very small amounts dispersed into tiny cracks deep in the bedrock. The team installed a deep collection system to prevent the residues from spreading. PCBs were not found on the site. CN Rail had implemented a federally mandated management and removal program several years before the shops were shut down. But the most extensive and painstaking part of the project was tracking down and managing traces of contaminants in the soil.
We set out a very detailed sampling plan that literally sampled every 100 feet across that property in 100 by 100 foot squares. And every one of those samples was chemically analyzed for a suite of trace metals and trace organic contaminants.
The almost 8,000 samples showed that about 20% of the site had traces of metal contamination. One of the most useful tools for the team in handling the huge amounts of data generated by the soil sampling program was a Geographic Information System, or GIS. Every soil sample was geo-referenced to the site, so the team could map locations with concentrations of metals such as copper, zinc, and lead. The GIS helped the team bring together the scientific data and their knowledge of past activities on the site. This line of contaminated test blocks follows the position of a rail siding near the repair shops, where cars, including those used in mining and smelting operations, were cleaned out before being repaired. The history of the site also explained why most of the metals were found on the top layers of the soil. This GIS map shows the distribution of elevated concentrations of lead on the surface and the locations where that contamination was deeper, as much as 1 meter down. As well as using the GIS for mapping, the team used it in a new way, as an environmental management tool to plan the removal of contaminated soils.
The GIS was able to tell us, by bringing this data to the screen, exactly where contaminants were, and it also allowed us to go in and determine how much contaminants we should remove from what locations.
The team used all the information they had to develop an effective management plan for metal-contaminated soils, the history of the site, the GIS maps, and the proportions of the different metal contaminants. As a result, instead of the expected $35 million headache, the team found a $2 million solution.
We found that they were very similar in nature to what was being mined in northern New Brunswick. And with doing some checking with the mine and showing them the concentrations that we had, it was determined that these ore-bearing concentrates could actually be utilized.
The provincial government agreed the soil could be transported for reuse in metal recovery. Approximately 4,000 30-ton truckloads of otherwise clean, metal-bearing soils were transported to the mine. Back in Moncton, with the areas of metal contamination excavated, the team looked at how best to use materials remaining on the site. What to do with a pile of excavated wood debris the size of a 20-story apartment building lying on its side, and 30,000 metric tons of soils with very low levels of hydrocarbon contamination.
The off-site removal was considered an option, but it was penciled off as much too expensive, so it was decided to evaluate the options of managing the material on site. There was a limited amount of area, so we did utilize the GIS as a positioning tool in order to determine the locations which those containment cells could actually, or soil management cells could actually be constructed.
Once the GIS had identified usable locations, engineers designed management cells that sandwiched layers of wood debris and soil with the clay on the site.
Basically, the levels of hydrocarbons will decrease, natural degradation of the material will occur. The metals will remain as they are in the cell itself. We don't anticipate any adverse effects associated with the metals in the cell. The berms are actually constructed such that they do provide a barrier between the sports fields or recreational areas and the surrounding industrial park.
Meanwhile, the final steps in preparing the site for redevelopment included reusing the broken concrete foundations of the old shops as a base and drainage layer under the future recreation areas. Nearby, in a former marshalling yard, soil samples had revealed the presence of arsenic, the only place on the site where this contaminant was found. The source turned out to be crushed rock that had been used for rail ballast. After confirming that the arsenic was of no threat to human health, the top foot of soil, which contained the remaining gravel, was stockpiled. It will be reused as structural fill supporting a new parking lot for the city's largest park. Throughout the remediation work, the bulldozers and trucks of the Moncton Shops project were guided by more than maps and data. Canada Lands Company was applying a powerful new principle for brownfield remediation: risk-based corrective action, or Rebecca.
Risk-based corrective action at a site recognizes the difference between a site where there's an unsafe condition and one where there's really no risk to human health or the environment. Unfortunately, before we had risk-based corrective action, governments were forced to mandate actions at a site that always had to protect the most extreme land use. So whether you were building a ballpark or a daycare, or whether you were building a parking lot, often you had to meet the same kind of stringent requirements.
They would set a number for lead, for example, it was 1,000 parts per million. You had to clean the site to 1,000 parts per million, regardless at what level or what location that contamination was at.
999 parts per million would have been fine. 1,001 part per million would have required excavation and removal, which really wasn't a very sustainable way of approaching things.
Risk-based corrective action assesses risk using scientific data about the type of contamination and exposure pathways. The calculations also take into consideration who will be using the land. The risk assessment sets criteria for how much contamination must be removed and helps set management objectives for controlling exposure to what remains. Redevelopment planning, such as strategically locating roads, parking lots, and buildings, can be very effective for managing risks on a former industrial site.
With risk-based management, cutting off the exposure pathways, which are air, land, and water, then you can probably achieve high success rates.
The bottom line is that we can make great decisions about what we can do at the site, but that we're ensuring protection of human health and the environment at all times.
As the scientific and engineering work for remediation progressed, the public information and consultation component of the project was put into place to involve members of the Moncton community.
We've tried to take a thorough an approach to examining all the ways that people could be exposed to contaminants and making sure that all those ways, at least from a scientist's point of view, will have no harm. Again, that's from the scientist's point of view. It's really, in the end, up to how people feel about it. How clean is clean? How safe is safe? What do people want?
To find out what people want, Canada Lands made public information and consultation a cornerstone of the project from the beginning. This helped to generate informed dialogue on the remediation as it progressed.
If you can't convince people and the community leaders that what you're doing is the appropriate and correct thing and that you're totally committed to the most positive end result, the best science in the world and the best plans in the world will not succeed.
Newsletters, open houses, public meetings, and presentations to students, business organizations, and community groups form the heart of the corporation's outreach to all segments of the community. A key element was an independent community roundtable, co-chaired by 2 community leaders. The 10 citizen volunteers ensured that the voices of the entire community were heard as they considered how to safely bring this brownfield back into use.
They represent the diverse interests of the citizens of Moncton, the students, the business people, the residents, former occupants of the site, realtors. So we really have a chance to get the views of all the people from our community.
The Roundtable's report, delivered early in the remediation process, reflected the community's concerns and gave specific recommendations for managing the site while endorsing the risk management approach.
I see a lot of environmental projects that are not successful because of the lack of communications.
It's the involvement of the stakeholders that in the end makes it a success.
After 3 years of work, the province accepted the remediation of the 65-acre eastern part of the site, confident that the cleanup and a site management plan would ensure continuing stewardship of the land. This gave Canada Lands the green light to start development of a 65-acre business park. For the remaining 200 acres of the site, with clearance sampling completed, final reports can be submitted in order to receive acknowledgement from the province that an environmentally responsible remediation has been achieved.
We're investing in this site because we feel very committed and very convinced that this site will reimburse substantial amounts of those investments.
Hundreds of hours of planning, analysis, and hard work, along with a $15 million investment, have prepared this site to rejoin its community. The new business park, the Moncton Commons Recreation Area, and a new residential development for the former marshalling yard will provide an enduring legacy. Claudette Bradshaw, the local Member of Parliament, has a very personal perspective on this brownfield redevelopment.
For me, as an MP, the importance is youth. And my life was given to youth. And I wanted to make sure that this land was going to be safe for the future of our city.
Canada Land's Chairman John Grant.
I'm reminded of a First Nations quote, which goes something like this: "We do not inherit the land from our ancestors, we borrow it from our children."
Maybe businesses can run off there too.
You see like something that's being productive, something that's being made, and I think that makes a big difference.
I see a lot of opportunities for jobs, businesses, for a job, possibly in the future.
As people who are living in communities, we're much more concerned about how we can coexist with the environment and how we can practice environmental stewardship.
Canada Lands has shown that brownfield redevelopment can present unique opportunities for sustainable development, especially for a community ready to rise up to the challenge.